Okay, this video is going to be about functions. We have already seen some functions, like the print function. So we've been taking notes in this file, notes.txt, and I'll post this on the course website. But when we're talking about functions, we're basically talking about things that are similar to commands from the Linux command line, right? There's a name of the command, like in this case it's the print function. And then you have left and right parentheses, and you can pass in argument data. All right, so arguments in a function are separated by commas. So I can say hello, and there, a classic example. Okay, so the function name, parentheses, enclose all of the arguments, and each argument is separated by a comma. Okay. And the print function can print out string data. It can print out almost any type of data. Okay, and we also learned about the round function that rounds a number. So if we have, 5.4, it rounds down. So let's actually create a new file here. We'll call this functions.py. Alright, so here's our print function, hello there, and then our round function, and we need to print that out if we actually want to see anything. Alright, so let's open up a terminal, change directories to our desktop where I have all these files. Let's see, I have strings, functions right there. Okay, so Python 3 functions.py. Okay, so there's the print function, the round function, right? We've seen lots of different types of functions so far. But what we're going to do now is we're going to make our own functions. Okay, basically what a function is it allows you to execute several lines of code whenever you want. Okay, so if I want to define any function, my function, I can have it take an argument, so I might have it take a number, and then we have a colon. Okay, now remember, so far whenever we've seen a colon, like in conditional statements, that means we're going to have a code block, which means we have to indent the code, and generally we're using 4 spaces to indent. Okay, so this is an identifier, just like variable names. The identifier can start with letters or underscores, but it can't start with a number. But the identifier can contain numbers as long as it's not the first character in the identifier. Alright, so we just called this my function, and I'm going to do a print statement that says my first function, and then I'm going to say x equals x plus 2, and then I'm going to print 2 times x, and then return x. Okay. So basically I've made a function, and every time I call this function, these lines of code get executed. Okay, so if I call my function, you do it just like you would call the print function. You use the name of the function, right? So here's our name, and then you pass it parameters or arguments. Okay, so in this case, let's pass it the number 5. Alright, so what this is going to do, every time I call my function, Python is going to go look up here. Is there a definition for this function in this file? Yes, here it is. So Python comes up to the function definition, and then it executes line by line every item in this indentation block. Okay, this is a code block for this function. So when we call the function, Python looks it up, and it says, okay, we'll run the first line. So it's going to print my first function to the terminal. Then it's going to take x, and it's going to say whatever was passed in here is x. I'm going to change that value to whatever x was plus 2. So we're passing in a 5. So that means up here, when Python's reading this line, x has already been assigned a value. X is 5 now. Okay, so I want to change the value of x and put whatever it was before, which in this particular case it's 5, plus 2. So after this line of code, Python says, okay, the number 7 is stored in variable x. Okay, so this should be 7. X should be 7 at this point. then Python will run this line. We're going to print out 2 times whatever is stored in x. In this particular case, it should be 7. And then we're going to return the value of x. So this print statement is going to print 2 times 7, which should be 14, but then it's going to return a value. Okay, so the return value, whatever value we return from this function, that is what the function evaluates to. So functions can be expressions. They can evaluate to a particular number. So in this case, we've passed in a 5. We changed the value of x to be 5 plus 2, so it's 7. We printed out 2 times 7, which is 14, and then we return that 7. So the value that gets saved here in return value should be whatever we returned from this function. So in this case, it should be 7. And so we'll print that out just to test it. Alright. So Python 3 and functions. So hello there, 5, that's our 2 rounding, that's our basic functions. Alright, so we don't really need these. So every time we call it, it runs that print statement, right? So we see my first function. We set x equal to 2 more than what we passed in. So this is the data we passed in, which is 5. So now x should be 7. We print out 2 times 7, right? So that should be 14. Here we go. And then the return value we got back from the function call is whatever we returned here. All right? So I can call this. What's really nice about this is all of this code is reusable. I can have a complicated algorithm here or a complicated process and as many lines of code as I want, and then anytime I just call my function just like that, all of that code will run really quickly. Alright, so what we could do is we could say print and then my function 9, 10, 24. Alright, so we're calling this my function, and then this time we're passing in 9. So 9 is the value of x. So when Python goes up here and it sees that we're calling this function, it goes up and looks for a function definition with this identifier, my function. It looks up in the code and it says, yes, we have one. Okay, so we're going to call this function and we're going to pass in this value for that argument. So we pass in 9. So at this point in the code, Python starts running line by line every line in this function. Alright, so x equals 9, then we print off my first function. Alright, then we're going to say x equals whatever it was before, which is 9, plus 2. So x should be 11, then we'll print out twice that, which should be 22, and then we're going to return the 11. Alright, so let's run that one. Okay, so my first function printed out 22, and the return value is 11. Right? So that's correct. The next one is 10. So that means x is 10. First, when Python sees this, it looks up for a definition of this function. If it sees one, then it's going to run these items one at a time. And you're passing in the number 10 for x. So x becomes 10. First line, it prints out my first function. Right? Then it says x equals x plus 2, so that should be 12. Then we're going to print out 2 times 12, which should be 24. Right? And then we return that 12. And then down here, this whole thing has been evaluated to the return value. So this whole thing is now essentially 12, okay, which is where we get the print 12 over here. Alright, so whatever you return from the function, it's as if this entire function call gets replaced with that value after the function has been called. And so any other expression you have here, like I could have plus 2 here. And so it's 12. This results in the value of 12 plus 2. Say it's 14. Okay, and then we'll try it again with another bigger number, 24. And we see x is 24. It prints out my first function right here. And then we have add 2 to the value of x, so that's 26. Print out 2 times 26. That's 52, and then return the 26. And then we print out that return value. Okay, so this is a simple function. The point is, whenever you call the function, Python runs one line of code at a time until it encounters the return statement. Okay, and you can have conditional statements inside of here, all sorts of other types of statements. If you need to add a conditional statement, there's an indentation block for that as well. Okay, so this is a conditional statement. If this Boolean expression evaluates to true, which it always will because this is a literal true, then this line of code gets executed. Okay, but then it continues down back one indentation level, and we'll go one line of code at a time. All right, so if we run this, indented. Okay, so you get reusability. If you write a complicated process or a complicated series of events, you can define it into a function and use it over and over and over again. It's very handy. It's actually a very powerful tool. All right, so let's look at a few other functions. All right, so one of the common functions that we have is print. Okay, so let's make a different version of that. We'll call it print twice. Okay, so we're going to define a function. def is the keyword, and then the function name. Okay, so this is going to be called print twice. So we're going to print out something twice, and we're going to have some argument that you pass in, and this is just a variable name. I'm calling this whatever I want. Okay, I could call it x, I could call it foo, I could call it arg. That's fine. I'm calling it arg because it's the first argument. Now the print function, normally when you pass it an argument, it prints it out to the screen. What we're going to do is use the print function and print that thing out twice. Okay. Now I don't have to have a return statement if I'm not returning a value. I can have one and return nothing. That's allowed. Or I can just leave it off, and by default Python will return none. Okay. So let's call this function. How do you call the function? You write the identifier name. So the name of this function is print twice. And we're going to print out foo twice. Okay. And sure enough, foo gets printed twice. So what's happening here is we're calling this function. Python, as we go down here, this is just the function definition. Nothing actually runs here. These lines of code don't run. All we've done here, it's kind of like a variable where we've assigned a value. So we've assigned a value to this identifier. This identifier means run this code. Okay. So now in Python, when we use that identifier, Python looks up in the code and it says, okay, do I have a definition for print twice? It looks up and it sees it and says, yes, I do. Well, then I'm going to run one line at a time until I get done with this function. And so we pass in the argument foo. So the variable arg holds the string foo, and then we print out the contents of that variable twice. All right. And then we'll print twice another one. And just to show you that it doesn't return a value, this should return the none type. None type means there's no value assigned. So we'll print that out, and this will be okay. So none is a special keyword that you can use to assign to a variable. So I can say some variable s equals none. Okay, that means it doesn't really have a value. Okay, if we look at the type of s and print that out, it's got a special type, none type. Okay, so it basically just means this variable is unassigned for the most part. So it's a special value that means null or nothing. All right, so if I leave off the return statement of this function, it's essentially like saying return none. So whatever value gets returned, if I assign this to a variable, I can say s equals the result of this function. That's essentially like saying, since I'm returning none, that's essentially like saying s equals none. Okay? Python sees this identifier, it looks up for a function. There it is. What's the argument? Dope. Arg equals that, and we print it out one line at a time, and then we return the value of none. So this whole thing essentially turns into none, and then s gets assigned the value of none. Okay, so that's the print twice function. We can do another function. Let's do the round function. And we're going to, actually, let's just make a function to divide a number by 2. Okay, so we'll call this function half. We're gonna make the number divide by 2. Let me save that. Save this. Okay. To define the function, the def keyword, then the identifier name, and again, it's just like variables. It can be anything you want. Can't start with the number though. Then you have left and right parentheses and a colon. Okay. Now in this case, we want to be able to pass in a number. Okay. The function half by itself doesn't really do anything unless we give it a number. Like, what do we take half of? Okay. So we need some variable to represent that number. So this is our one argument. Okay, so what we're going to do is we're going to say a variable h, which is going to stand for half, is going to equal x, the value of x, divided by 2. And then we're going to return h. Okay. Now let's print out the result of half, 12, and half, 21. Let's do 31 instead. 33. Alright. Go back and run Python functions. Okay, so half of 12. Python sees half here. This is an expression. It's one function call. In order to evaluate this expression, Python has to look up for this function definition. Do we have one? Yes. Then it takes the arguments and plugs them into the variable names here. Now we create a variable called h, and we're assigning a value to it. Okay, so h now holds whatever x was. So in this first function call, x is 12. So 12 divided by 2 is 6, and that's the value we return. Notice this is floating point decimal data. Okay, that's because division by 2 can result in non-integer values, so it automatically makes any division, Python returns a floating point decimal. Okay, so half of 12 is 6, and then half of 33. Again, Python looks up the identifier half, it sees it, takes this argument and plugs it into these variables. Whatever we have there, we just have one. H equals whatever x was, which is 33, divided by 2. Okay, and then we return that value. So then this value becomes h when we print that out, and that's 16.5. Okay, so you get reusability from these functions. I can define half round. Well, let's say I wanted to round that number. I wanted to take half, but I always wanted to have an integer. Okay, so I can define a function called and I have some variable x, and I have to use my colon. That means there's going to be an indentation block. Alright, so half is going to equal x divided by 2, and then I'm going to return, instead of just returning h, I'm going to return round h. Round is a built-in function that rounds a number. Okay, so this will round that number. If I have 16.5, it will round that number. And then we can just call these two again, except we have to change them from half to half round. Okay. So we're calling half round now. Python sees that. It looks up here for the function definition. It sees we do have one. It finds the 12, plugs that in to the value of x. 12 divided by 2 equals h, and then round that. So that one should still be 6. And then the other one should round. Okay? So Python rounds 6.5 down instead of up. If we do 6.5, if I did 33.1, that would round up. Pretty sure. Yeah. Oh, that rounded down too. Interesting. Okay. But notice that there is no decimal value here, right? So these are integers. There's no .0. So round always returns a rounded number to the closest units digit. Okay, so the closest units digit means that it can be displayed as an integer. So Python makes the type of this data integer. All right. So that's another example of a function. So with the print function, let's do another version of print twice. This one's a little bit. This one's going to be a little bit better because when I print something, I can print multiple arguments. I can say foo, bar, and baz, but I don't know how many arguments I'm going to have, right? So here, like I know I'm going to have one argument because I've defined one argument. With the print function, you can have as many as you want. So I'm going to show you how you can do that in your functions. All right. So we define a function called. This is a better version of print twice, so we'll call it the good print twice. Okay. Now before on print twice, we just had one argument. Okay. If I would try to call print twice with multiple arguments, I'm going to get an error. Oh. Okay, print twice takes one positional argument, but two are given. Okay, that's because here I'm calling print twice. Python looks up for the definition, and it sees that there's only one argument defined, but I'm passing in two. And Python's like, wait a minute, can't do that. And then it stops. It throws an error and it breaks. And it tells you where the error is. Okay. So what I'm going to show you how to do is be able to have more than one argument, or just one if you want. Okay. So instead of specifying arguments here, like we could have x and y, and then we could just print out x plus y. Right, that's one thing we could do. Let's just call this add, and we'll do the good print twice next. Okay, so this is just going to be add. I'll put that down there. We're going to return x plus y. So I can say x equals add 5 and 7. And then I can say y equals add 2 and 22. Okay. X and Y in this function only pertain to this function. X and Y out here are a larger scope, and they do not pertain to the X and Y in these functions. Okay. So if I have an X and Y in here, the X and Y inside the body of the function refer to the X and Y provided as arguments. Right? I'm just reusing a variable name here. We can call this anything we want. We can call it A and B if that's easier. Alright, so we can print out A and print out B. Okay, so this is let's just put a little label in here so we can see where we are. So this is add, right? And so 5 plus 7, sure enough, is 12. So Python looks up for this function definition. It sees it, and it says, okay, we've got two arguments, 5. So x is going to equal 5, and then we pass in a 7. So y is going to equal 7, and we return this expression. This expression has to get evaluated fully to one single value before the function can return. Okay, so this is going to be 5 plus 7, which is 12. So the return value is 12, which means this whole thing essentially becomes a 12. Alright, same over here. Look up add. X is 2. The first argument is x, so 2 gets stored in x. The second argument identifier name is y, so 22 is the value in the function call. So 22 gets stored in y, and then you return 22 plus 2, and that's 24. Okay, so this is really important. This part with the DEF is the function definition. The DEF should tell you that. None of this code runs when you have a function definition. It only runs when you call that function. This is a function call. You are looking up this function and then running those lines one at a time, and also providing argument data to these variables. Okay, this is a function call and a function definition. Okay, so on a test you might see which actually runs code, a function definition or a function call, and the correct answer would be a function call. This is when the code actually gets run. This is just defining what code to run in case I do call the function. So down here is where I'm actually calling the function twice. Okay, back to our print twice. So this is going to be our good print twice. Okay, so normally in the print function you can have multiple arguments, right? But we don't know how to do that yet. We can only have a specific number of arguments, like in this add or up here in round. So what you can do for a specific number of arguments, or not a specific number of arguments, is you can add this little asterisk, and basically any arguments that they type into this function all get collected up into this object called args, this variable called args. This is a collection of items. This is called a tuple. We'll probably get into that later. But all you need to know is you can pass that directly back in to print like this, args. So let's say in this case I typed good print twice and I passed in these arguments. Okay. So good print twice, and I want to pass in a bunch of arguments. All of these get gathered up and plopped into this variable. That's what this little star does. Okay, so this variable actually contains all of these values. And then when I use the star again, it ungathers them and spreads them out as individual arguments to print. Okay, but remember we have to print twice because that's the name of this function. Okay, so now good print twice is going to print foo bar baz. Okay, and there'll be a third one because of this one up here. That should be good. Okay, so here's the first one, foo-bar-baz. So we can pass any number of arguments to print that we want. The way that works is using this kind of style. All right, so if you want the user to be able to type in any number of arguments, you would use something like this. All right, good print twice. All right, let's see what else. So we learned how to replace text. All right, so let's use the string replacement, the method that we learned, string.replace. So we're going to make a function called replace cat with dog. And we're going to pass in some string value s, whatever that might be. And we're going to return s.replace any instance of cat in that string. We're going to replace that with dog. So now I want to say I'm going to have some sentence. Alright, now we're going to, we can print out that, and then we're going to say change the value of words to be replace cat with dog, and we're going to pass in words. Okay, so Python sees this. It says replace cat with dog. We're looking up the function define. It sees that there is a function called replace cat with dog, and the variable s is going to hold whatever we pass in here. So words is holding this text, so we're passing in that text here. So s, when this function is called, s becomes this text. Okay, and then we say s.replace any instances of cat with dog. Okay, and this is getting returned from the function. Okay, it's very important. The return keyword tells you what value, when you call the function like this, what value essentially gets returned from this function, right? So if I don't have a return value, that value would be none. If I do, in this case, it's going to be the same string, except every instance of cat is going to be dog. Okay, and now we'll print out words again. And this one should have dog. And I love dog. So every instance of cat was swapped out with dog, even though it was plural. It doesn't matter. It sees CAT and it replaces it with DOG. And I can use this function over and over for whatever I want to use it for. Right? That's the beauty of functions. The reusability. It's a core principle in computer science. If you write a complicated piece of code, write it so it's reusable, so you don't have to do the same thing over and over and over again. Okay? Let the computer do that sort of work. Alright. So we'll do one more function. This one is a little bit tricky, but it ties into strings and ASCII character data. And we're going to learn our first loop here. Alright, so every string has a built-in method and I can print s, and I can print using the built-in method s.lower, like that, or s.upper. Okay, some text is the original, this is lowercase, this is uppercase. Okay, so what we're going to do is we're going to make our own uppercase function. Okay, this is basically showing you how this function here is made. So we're going to define our own function called my upper. All right, and we're going to pass in a string. Okay, so first things first, let's just print out s and make sure everything's working right. So my upper. There's the function call. I have to pass in some data. So we'll pass in hello, exclamation point. Alright, so hello should come in as S, and then we should print out hello. That's all this function should do so far. There it is, hello. Alright. Now what we want to do is for each character in this string, we have to deal with them one at a time. Okay? So this is where the for loop comes in, and we're going to learn more about loops later. But basically a loop allows you to do a certain block of code repeatedly for all items in a list. Okay? So for character in S. So for every single character in the string S, that character is going to be assigned to this variable name. Okay, I can call this whatever I want. I'll just call it C. So C is going to hold one single character. And again, we have a colon, so that's going to be an indentation block. So we print out C. Okay, so remember, S is this string. There are 1, 2, 3, 4, 5, 6 characters. Okay? What this for loop is going to do is C is going to become the H the first time through this loop, and then we're going to print out H. Then C is going to become the next character, E, and we're going to print out E. Then this variable C is going to become the next character, L, and then we're going to print out L, and then L, and then O, and then exclamation point. So this loop allows us to execute the same code, but there's one variable that changes. This variable C changes and becomes each of every single item in this string, every single character in that string. So we see H-E-L-L-O, exclamation point. Alright. So we have the different types like int and float. We can convert things to an integer with the int function. There's a function called ord, which stands for ordinal, and it gives you the ASCII value of a particular string character. Okay, so we have a character, and we're going to store that variable or that number in here. Okay, ordinal gives us the ASCII number of that symbol. Okay, so C is the actual character. Right? So C was H, then E, then L, L, O, exclamation point. O is going to be the ASCII number associated with that character. Okay, that's what the ord function does. It returns the ASCII number. Okay, so we'll print that out right next to each one of these characters. Okay, so H is 72, E is 101, L is 108. Now let's look at our ASCII table and see if that's correct. Alright. So we've got ASCII table, and capital H is decimal 72. So what we have, 72. E is 101, lowercase e is right here, 101. L is 108. L is 108. Okay, so this is cool. We have a number value associated with that particular letter. That's nice. Okay, so what we can do with that is we can determine if it's in this range. If that number is between 97 and 122 inclusive, then that means it's a lowercase letter. And if that is a lowercase letter, then we need to make it uppercase. Okay? So basically we want to check to see if it's a lowercase letter. Alright, so if O is a lowercase letter, so it's a lowercase if it's greater than or equal to 97 or less than or equal to 122. If O is greater than or equal to 97, and it's also O is less than or equal to 122. It has to be both. It has to be higher than, it has to be 97 or higher, right? 96 is not a lowercase. None of these down here is lowercase, so it has to be 97 or higher. But if it's too high, if it's 126, that's not a lowercase letter either. So it has to be above 96 and below 123. So it has to be both. That's why we use and. Both things have to be true. Okay, so if the ordinal value is greater than or equal to 97 and also less than or equal to 122, then we know we have a lowercase value. So if it's a lowercase value, we need to make it uppercase. So how can we do that? Well, if this is 97, the uppercase value is 65. So what's 97 minus 65? Just to be sure, we can open up a Python terminal and say 97 minus 65. Right? So the difference is 32. Okay? So if we just subtract 32 from our number, 97 minus 32, 95 minus 30 is 65. We get the uppercase version. What about B? Let's subtract 32 from 98. That's going to be 96 minus 30 is going to be 66. Uppercase B. So all of these, we just subtract 32. So if our ordinal number is between 97 and 122, then we're going to say take that ordinal number and store in it whatever was there before minus 32. And then we convert that back to a character with the CHR function. So ORD gives you the ASCII value of a number, and CHR takes a number and gives you the character representation, the ASCII character for that number. Okay. Okay. So this is going to return a single character, and if it was lowercase, we're changing the ordinal number so that this will be an uppercase value now. All right. So first we have to make a variable up here called up, and this is going to hold our new string that we return. And we're going to say up equals whatever it did before plus this new character. Okay, so the first time through the loop, C is H, capital H. The ordinal for that is 72. Okay, is 72 greater than 97? No. So we're not going to do this. And then we say up, this is our final value that we're going to return from this function. Alright, so up is going to equal whatever it did before, and it started out empty. There's nothing in it, just the empty string. Okay, up is going to equal whatever it did before plus the character version of this ordinal number. We didn't change the ordinal number because this was false, so we didn't change it here. So it's just going to be the same letter that it was. It's going to convert it back to a capital H. Right? So up now equals H. Now the second time through the loop, C is an E. What's the ordinal value of the letter E? We look over here, it's 101. Okay, so if 101 is greater than or equal to 97, that's true, and 101 is less than or equal to 122, that's also true. Both of these things are true. Okay, so then we're going to change the value of O because we want to make it a capital letter now. So we say O is whatever it was before, which is 101. We're going to subtract 32. Alright, 101 minus 32 should give us 69, which would be a capital E. Okay, so there's all these mathematical patterns to all of this stuff. So the simple function s.upper, that seems so obvious to us humans, what's going on there? Something like this is going on in the background. And you need to start thinking like this if you want to be able to communicate with computers and get them to do very, very helpful and powerful things. Okay, so you have to be very specific, tell it what constraints to look at, and conditionally run certain code. Right? So if we run this again, my upper, hello, and we'll just have it print out the result. so we'll exit the interactive mode of Python, and here we go, functions. Okay, some text. Here's hello, and notice we passed in hello lowercase, and the final product, the result, was uppercase. And that's just like printing out the built-in function. The built-in function dot upper. Okay, so we made our own version. I know this is a little complicated, but I wanted to show you something a little advanced. And this will get you thinking about loops as well, which is going to be one of the upcoming topics. Okay, so that's enough for functions. I recommend you try to play around with these, and you're going to need them for the lab coming up.